the first versions of Gensyn will be open, but open in the sense that the person that you send your computation to will be able to see that computation, but nobody else will. There's some really interesting techniques you can use to obfuscate and encrypt that data and that model. So the first kind of approaches we'll have once the initial Gensyn network is out are to use functional encryption, where you can actually turn the first layer of a neural network into a functional encryption key, which is homomorphic over the rest of the kind of network itself, which, long story short, and not getting too technical, means that you can train on ciphertext. So you encrypt the data on the submitter of the model's side, you send the model out, and you send the encrypted data out. It trains on the encrypted data. The person who's doing the work never sees the real data itself. They just see this model and the outputs, and then they send the results back. There's some downsides. You have to encrypt in order to use the model in the future. There's a slight performance hit. There are attacks that you can do. There's model poisoning, and there's kind of extraction techniques you can use on a model to find out about the data. But it's an approach that you can take. There's also some even simpler approaches around secret sharing and secure multi-party computation, split neural networks, and things where you just shard up the whole computation so that everyone gets a little piece of it. You can still do that with neural networks where you just split them all up. Everyone is training on a portion of the data. They don't know what portion it is. And then in order for them to extract it, they would all have to collude, which is something we're very familiar with in the crypto space around stopping that from happening. So it's not it's not an unforeseen problem, essentially. So yeah, there's lots of kind of techniques you can do with the data. And then model privacy is essentially only fully homomorphic encryption which can solve that, which is encrypted model, encrypted data, run a fully encrypted computation. But that's for training probably a few years away. Some people think forever away. We're more optimistic, given what we've seen the space progress, especially around zero knowledge proofs recently, that there's a lot of thought going into this space and there's a lot of things happening. And there's companies like Zama who are doing fully homomorphic encryption for model inference right now and doing it quite successfully. So it's a space that we watch very closely and we will incorporate into the network one day. But like I said, 50% of the kind of users don't really mind. And we can expand on why. The big reason is everyone's training reference model architectures on open data sets right now. So the model architectures get published through archive or research journals and things like that. And the data sets are things like Wikitext or ImageNet or Flickr, where they're huge, curated, labeled open data sets that are required to get these models off the ground. And then when you do that training on a kind of secret data set, you do a little bit of fine tuning on that data set. It's easier to do that locally, and also we can do that encrypted with the data privacy portion.